In this section, chapter 4, everything about polynomial and rational function, the main tool here is a long division, dividing two polynomials, dividing one polynomial by another. And this technique is probably the most important technique that is used in entire algebra. If we do something behind it, this is an important idea. So although it's tedious and kind of simple, but it happened to be the major tool in the entire, even in higher mathematics, and that uses algebra. So that's something we're going to do. And we talk about the typical question, what is the zero? How do you solve the polynomial equations? And think about a little bit of more complicated, but very, very simple stuff about rational functions. In calculus, you learn more about rational functions. That's a better tool there. So we focus on dividing polynomials. But let's so here the two methods of dividing polynomials. Something is called long division. It's a general method, like it says, it works all the time. There's another one that's called a synthetic division. It does not work all the time, but your divisor is a linear divisor, such as x minus 2, x plus 5. Those are linear divisor. X squared minus x plus 1, that's not linear divisor. It's a quadratic divisor. If your divisor is linear, then synthetic division is a quick, and so that's why we do this. Is a lot quicker than long division. You write less, and it works a lot faster. So you'll get used to it, but you need to know long division as well, right? And sometimes there will be a simple problem. It says use a long division, not synthetic division. You have to follow the instruction. You have to know both of them. So especially this is misunderstood a lot because there's sources out there in WebAssign, and there's internet and Khan Academy and things like that. They do the division, and that's all correct. But at the end, think about why we're doing the division. To produce identity, right? You learn identity, right? Identity is looks like an equation, but how many solutions are usually there for that equation if it's an identity? Infinitely many. Think about trigonometric identity. No matter what you plug in, they're always satisfied. That identity is the important thing in mathematics. Not just you do things and get some two numbers out. What does that mean? It means this division identity, and you have to know, kind of summarize the thing that you do here into a single identity. That's why we're doing this division algorithm, right? So I'm about to introduce what that is by doing something you already know or something you have forgotten long time ago. All right? So we have a calculator, and nobody does this anymore, but you got to get back to it. You need to understand this mathematics behind it. We're not here, try to do this really fast or anything. We need to understand how this thing works, right? That's why, you can use a calculator, but you need to understand how this division thing works, and that's where we're back. So we're dividing 233 by 17. I wrote example, so I'm not going to offend you with doing this one. So I'll think about this one whole together. 233, we're about to divide by 17. Is no battery, no electricity, nothing. You got to divide it. All right? And you put 17 over here. Have you learned any of this? Yeah. 233 there, 17. Think about how many multiples of 17 is going in by dividing this number into blocks of digits, right? You look at the first digit, 17 is not going into 2. You look at the next to 23, right? So you put lines like that in your mind. Oh, 17 goes in 23. Not 2 copies or 3 copies. Only 1 copy goes in there, right? So you write down 1 copy, and 17 is out there. So what is it? Is that 6? Up to 6. 6 in there. And 6, and then you have to, this is like 233 minus 170. That's what this one is. This is 1, but it's really 10 because of the place. So 233 minus 170. So it is really 63. But you only do this part of the subtraction and just put this 3 down, and that works. Then you think about next number. If it has more digits, you have to carry all the digits down there, and then think about which block, least the size of the block the 17 goes in, and how many thing goes in there. Not 5. Is that 3? I think I did that before. I kind of remember. So this one, I would first match this 6 in there. I will put 6 there because it's a 6, and I have to multiply 6 to match that. That's too big. And I would cut down into half of it. And if it is too small, you go down to the next half of up. So that called bisection method really finds it really quickly, actually. So here's 3. Then what is it? Is that 51? 3, 21. The 51. Now you subtract, there's nothing else to carry down. And if you do that, what is it? Is it 12? All right. Now you think about there's no more number putting down, and 12 is already smaller than 17, right? So you stop it there. That's the end of this division algorithm. Correct? You stop it there. When do we stop? The size of this number is smaller than 17. Right? That's where it stops. So let's introduce some terms. What is this 17 called in this division, I think? Not coefficient. That's the divisor. Thank you. That's the divisor. What about this number 13? I remember this name. This one is called quotient. How about this 12? Remainder. Thank you. So this most unpopular name in here. What was this 233 called? Wow, that's impressive. That's dividend. Is that how you spell it? E-N-D? All right. So those are the terms. It's going to be exactly the same thing for the polynomial. But I answered that. What are the quotient and what are the remainders? I answered it, right? Quotient is 13 and remainder 13. So here's the key. That is the main thing. So what is the division identity you're talking about? So here's the division identity. Part C. By doing all that, what you have accomplished is that 233 is decomposed into sum of two things. That's what this identity is about. The first thing, the second thing is the remainder 12. Who knows the first term? 13 is not the answer. 13 times 17 is correct. 17, divisor comes first, and multiply by the quotient. After that, if you add remainder, you get back to the original number, 233. What is the name of this one? Division identity. Nobody calls this one division identity, just me. So that we can identify what this one is with words, right? Where everybody knows, oh, division identity. And I'm going to ask you to state the division identity. What happens if you... That statement is called division identity, yeah. If you don't state this one, half of the credits, right? So you do all the difficult work not stating this one correctly, right? All right, what is that part D then? Division identity in quotient form. Again, nobody calls it like this. This is the name term I created so that we can identify quickly what that one is. So you know what happened if I actually divide both sides by 17? So you have 233 divided by 17 in here, right? Then 17 must divide this one and that one. Is called distribution law. You have to divide that. Then you see 17 cancels. Therefore, only 13 remains. Correct? And here 12, there's no copies of 17. This is supposed to be smaller than 17. So you write it like this. So what is this fraction form called? Is a proper fraction, or there's a term for fraction that 233 divided by 17 is turned into 13 and 12/17. That there's a name for that, but that's what I call the division identity. In quotient form. Quotient form is pretty easy. You write down 233 divided by 17. Quotient here, remainder divided by divisor, right? So that's what that is. So you actually, if you divide it by 233 in calculator, what comes after the dot, decimal place is exactly equal to 12 divided by 17. And we use that to, all right, if 5,000 RPM and how many rotations involved, we divide that by 2 pi and 330 is 360. You looked at the fractional part, and that's, we once looked at it before. All right, any question about what this division identity is? And division identity in quotient form? Good enough? But none of this is going to be on the test, right? Is what's going to be on the test is the polynomials. So you have to learn this thing, how this thing works with the polynomials. All right? So there's a polynomial. You better write an expanded form, and here is a task. Divide polynomial by another polynomial, right? So I'm going to review this one for you and how you do that. That's an example. All right, ready? Oh, this is going to be long division. Thank you. It's long division. Thank you. This method is going to call the long division. All right. So what do you think is a dividend and what do you think is a divisor? Right, the quadratic polynomial makes sense. Quadratic with degree 2. That you write it down in order. That's very important, in order. I'm going to swipe this around in the test. You have to put it in the correct order. Highest degree, next one, 26, and plus 12, right? What if there's no x in it? What if there was a 6x squared plus 12? And you will insert a place, like empty place, there for x to the first, all right? If it is missing a term. And have a little place ready there. And then we draw this thing there, right? And you write down divisor also in the correct order. If it also misses one of the term, and that's also a good idea to have a space. And all right? In my opinion, to choose what to put up there for the quotient is a lot easier than actual division of numbers. You have to think about it and adjusting. And I still remember when I was a little kid, choosing this number. I'm very sorry about this, and I have to decline it. Forgot to turn off my phone. This is not easy to choose a number if the sizes are pretty big, but here's a lot easier, right? What you have to do always is that you always pay attention to the leading term. That's called the leading term of a divisor, right? And the leading term of dividend. This is the dividend, right? I'm going to call whatever that's inside of here, I'm going to call that the intermediate dividend. We're going to subtract it out. You have another one. You have to keep working on that, just like we did a number. Those are kind of intermediate dividend. Always pay attention to the long leading term right there. Make sense? So how are we going to match? What should I put in here so that I match these leading terms? Yeah, 6 must be there, and I have to multiply some powers of x to match that. It was a 6x, right? If it is 5, you have to multiply x to the 4th, right? Whatever that you multiply these two to get that. So that's how you get this one term in the quotient part. Make sense? Then after that, you actually have to multiply 6x that you chose to not only to x but everything. So first you do that, 6x squared. And you also have to multiply this one down there. That's negative 24x, correct? And then that's it. Since that divisor only had 2 terms, that's what you're going to do. And then you just draw a long line there, right? Then what did we do in the division of numbers? You subtract. So have a habit of just putting the negative symbol there. And actually show me to the side here in your answer. Side note, show me you're actually subtracting. For example, there's negative 26 up there, right? Do you see the negative 26? And you're subtracting down there negative 24, right? And then what is it? Do you see that as a negative 2? So you write down negative 2 and x in there. Right? If you get perfect answer down there, I'm happy. You got the full credit. But if it is wrong, and then if I'm not able to understand what on earth you're doing in the middle, you're going to get 0. But if you have this thing written down, and if I detect, oh, that was a little mistake. Oh, he's doing it again. Oh, he's doing it again. Then it's not a mistake. But if there's one spot it's a tiny mistake, I can take care of it. That's no deduction from there. So I need to see this really, because many students overall, I'm subtracting, I'm going to change it to positive, all sorts of things going on. After you just, if I look at a final version, very difficult to understand what happened in there, all right? So have these things right in there. All right. How about this one? 6 minus 6, 0, right? How about this one? That's a 0. So 12 minus 0 is just 12. All right? That's what I mean by intermediate dividend. All right. So think about when to stop this one. It is not the size of these numbers, it's about the degree of the polynomial. What is the degree of this intermediate dividend? Right, it's x to the first, degree 1, right? And what is the divisor of the degree? Degree of the divisor? 1, right? It's still not lower. And then you go one more time. Until the degree of this remainder is strictly smaller than the degree of a divisor. Then you stop. Alright? So you have one more to go, right? Will you do that for me? So let's finish that. Exercise number 2. And exercise 3. Do one more. Step. 2 is correct. The other one was one exercise with two problems. All right. Exercise 2. All right. Was that okay? There's no x needed. Just a constant. If you multiply to x and you match this negative 2x, so I put the constant and you multiply these two numbers there. Then you have positive 8. When you subtract it, you write down 12 minus 8. So I have 4 down there. 4 as a constant is degree 0. Right? So you can look at it as a 4 times x to the 0. Since x to the 0 as an indeterminate considers 1, so that's why I call degree 0. Make sense? Alright, so do we have one more step to go? No. This is degree 0 is less than degree of divisor, right? This is where we stop. Okay? That's the answer to exercise number 2. Alright, here's your challenge. That exercise number 3. Do you know what that's going to be? That's right, yeah. You get a bonus point. Give yourself 1 point. State the division identity. Yeah, we did all that. To not test you, you can follow instruction. To produce this identity, right? The statement. Think about what that division identity for number were. It's exactly the same thing. Was that okay? Here's a dividend, the quadratic polynomial, and here's a divisor, multiplied by quotient, and after that you add the remainder. Right? So this polynomial is broken into 2 parts like that. And this decomposition is used a lot in higher mathematics. Okay. So the thing is that our goal is to choose this divisor so that this turns out to be 0 rather than 4. Right? If it is 0, isn't that a nice form? It's called factorization. Right? So that's the goal. If this guy has degree 4, we look for this linear divisor. So you divide it, the remainder 0, then you end up at factorization. So the method of factorization is something that we do here, and we use this division algorithm. Okay. Any question? All right. And then stating this division identity in quotient form is easy, so we'll just do it here. That's 6x squared minus 26 plus 12. If you divide that by x minus 4, and what's in the right-hand side? Is the quotient itself. 6x minus 2, the quotient itself, right? Plus, what's in the numerator is the remainder divided by the divisor, which is x minus 4. And you cannot further simplify. This is as simple as it gets, the second term. This whole thing is called division identity in quotient form. Okay? Make sense? So if you sketch this function, you know there is this polynomial point. How does the 6x minus 2 look like? That's a line, right? How about 4 minus x minus 4 when x is like 500? 4 divided by 500 minus 4 is pretty big number in the denominator, so you figure that this is like 0.00 something, right? So if you sketch this function looks a lot like 6x minus 2 if x is big enough. These are called slant asymptote or something. Alright, so here's the next task. do the division algorithm and check the quotient and remainder with me. Then we're going to enter division identity. Okay, that division identity is written here, so let me actually delete it so that you have to remember this. Question is a state. The division identity. That's exercise 4. Using the long division. So what is the degree of the divisor here? This is the divisor D. 2. So whatever the synthetic division that I haven't introduced is not, you can't do that here. This must be long division, right? So do you notice anything about this px? Something special about px? X to the third is missing, right? So you got to have place x to the third there, right? What's that? I think that's a good idea. Rather than having an empty space, it's kind of weird. You can put, why don't I just put like that? So you put something there, all right? Instead of having an empty space there. I think that's a good idea. All right, you ready? So, how was it? Was it all right? And sometimes it rarely happens that you knock down the 2 terms. You know, that doesn't usually happen, but it could happen. So for that, you got down to degree 1 remainder, so you don't go anymore. But I occasionally see that students just keep writing down, oh, I have space here, and I'm going to keep doing that. And then you have like 1 over x down there. I still have that solutions. Right, it's a degree. It's a degree 1, that's degree 2, right? Lower degree, that's where you stop. That's right. Any other question? But this would be half credit, right? This would be half credit. So what is a full credit answer? Would be following 8 times x to the 4th plus 6x squared minus 3x plus 1 is 2x squared minus x plus 2 times 4x squared plus 2x, and out there negative 7x plus 1. That's our final answer, right? This is our answer. That's the division identity. Any question? Can you imagine that you have down there in 3x to match? Then you have 2x squared, right? So down there, let me just have, here's a 3x there you have to match. Then you have a 2x squared, let's say 3x squared there, third. What should we multiply in here? Sure, you have to multiply x there, right? But what should we multiply to get 3? Right, you got to have 3 in there, and 2 is not helping, so you got to get rid of it by putting it underneath there. Right? So you can see it can get really ugly if I put random coefficients. If this coefficient is 1 instead of 2, then it always works. You can always easily multiply whatever 1 times whatever's out there. So if it is 1, we're happy. And if you see, oh, my divisor had leading coefficient 7, and then you're being nervous. You're gonna, I'm gonna have a lot of these, and I'm gonna bound to make mistake eventually. Things like that. All right, that's long division. This is a nasty one. Yeah, from the beginning, it's just like. Oh, that's right. I didn't mean to. All right. Any question? Minus, you can put minus outside. That's fine. Yeah, or put it up there. All right, that's long division. Now, what's politicians just try to remove this from curriculum, but we got to keep it. This is very important, for our humanity. This is very important. I'll see you next week.